probability of A or B is equals to the probability of A plus the probability of B minus the probability of A and B. In 11.1, we have events A and B that are mutually exclusive. It is given that the probability of B is equals to 2 the probability of A, and then the probability of A or B is equals to 0.57. So let's go ahead and make sense of that. We have the probability of A and B. If two events are mutually exclusive, then the probability of A and B occurring at the same time is 0. If two events are mutually exclusive, they cannot occur at the same time. For instance, it cannot rain and not rain at the same time at the same place. It is not possible. Those two events are mutually exclusive. It's like you cannot pass and fail at the same time. It's either you passed or you failed. They cannot occur at the same time. So now we can say that the probability of A or B is equals to the probability of A plus the probability of B, because the probability of A and B occurring at the same time is 0. So what is the probability of A or B? We have 0.57, which is equals to the probability of A plus the probability of B. The probability of B is 2 the probability of A. So we're going to have 2 the probability of A. So 0.57 is equals to 3 the probability of A. So now it's just a matter of dividing both sides by 3. If we do that, we're going to get the probability of A being equals to 0.57 divided by 3, which is equals to 0.19. So this is the probability of A. But don't forget, we're not looking for the probability of A. We're actually looking for the probability of B. So now we can say that the probability of B is equals to 2 multiplied by the probability of A, which is 0.19. If you put that in your calculator, you should get 0.38 as the probability of B. That is 11.1. Let's look at 11.2. A box of 40 calculators is sent to a store by a supplier. The owner of the store is not aware that 5 of the calculators are defective. 2 calculators are selected at random from the box, the first one not being replaced before the second one is selected. Right, and then 11.2.1. What is the probability that the first calculator chosen is not defective? Right, so this is actually easy to compute. The probability will be equals to how many calculators do we have? We have 40 calculators. And then how many calculators do we have that are not defective? That is 35, because only 5 calculators are defective. So it means that the remaining 35 are not defective. So the probability of picking a calculator that is not defective will be equals to the number of calculators that are not defective divided by the total number of calculators. And this will be equals to 0.88. The answer to 11.2.1. Let's look at 11.2.2. What is the probability that if 2 calculators are selected, one calculator is defective and the other is not? So I want us to really think about this. We're looking for the probability that if you take 2 calculators, one after the other, one of the calculators will be defective and the other is not going to be defective. So this can happen in 2 ways. It's either the first calculator is defective and the second calculator is not defective, or the first calculator is not defective and the second calculator is defective. So we're saying that is the probability that the first calculator is defective and the second calculator is not defective, plus the probability that the first calculator is not defective and that the second calculator is defective. So let's go ahead and compute this. What is the probability that the first calculator is defective? What is the probability that the first calculator is defective? It is 5 divided by 40, because when you start, you're gonna have 40 total calculators, and then there's 5 of that 40 that is defective. Multiply by, now you're picking the second calculator. You're not putting the calculator back, you're picking the second one. So now you're left with 39 calculators. How many calculators do you have now that are not defective? You still have 35 calculators that are not defective. So this is one way our scenario can occur. Then plus the probability that you start with a calculator that is not defective. If you start by picking a calculator that is not defective, then the probability of that is 35 divided by 40 multiplied by the probability that the second calculator you pick is defective. So now you're left with 39 calculators in total. And how many defective calculators do you have now? You still have 5 defective calculators. And then if you put that in your calculator, you're gonna get 0.22, 11.2.3. What is the probability that if 2 calculators are selected, both are defective? What is the probability that if 2 calculators are selected, both are defective? Let's go ahead and find out. So the probability will be equals to. So you pick in the first calculator. When you pick the first calculator and it is defective, you have a total of 40. And the number of calculators that are defective is 5. And you happen to pick one of the calculators that is defective, then the second calculator you're gonna pick, now you have a total of 39, but the number of defective calculators that you have is now 4 instead of 5 because you've already picked the first one. So it's just a matter of multiplying these two numbers. If you do that, you're gonna get 0.01. So it's very, very unlikely that if you pick 2 calculators one after the other, you're gonna pick 2 defective calculators. Right, let's move to 11.3 and 11.3.1. We have 4 different economic books and 3 different life sciences books that are required to be placed on a shelf. Then 11.3.1, if you decide to place any book in any position, in how many different ways can you arrange the books on the shelf? So how many books do we have? We have 1, 2, 3, 4, 5, 6, 7, right? So on the first slot, we're not required to peg them in any order. On the first slot, you have an option of 7 books, and then on the second slot, after you've placed 1 book, you have an option of placing 6 books. After that, you're gonna have 5, 4, 3, 2, 1, and this is just 7 factorial, right? The answer to 11.3.1. 11.3.2, if 2 particular books must be placed next to each other, in how many different ways can you arrange the books on the shelf? So let's go ahead and have our spaces again. So we have 1, 2, 3, 4, 5, 6, 7. Let's say we have books A to G, just for the sake of clarity. So let's say on the first slot we have A and B, right? And then they must be close to each other at all times. And then on the other slots we can have C, D, E, F, G. These 2 books must always be close to each other. These 2 books must always be close to each other. So instead of taking those as 2 slots, let's take them as 1 slot, because they must always be close to each other. So now instead of having 7 factorial, we actually have 6 factorial. 1, 2, 3, 4, 5, 6. So there's 6 factorial ways we can arrange these 6 slots now. But you have to realize something. This first slot, there's 2 factorial ways of arranging it, because you can put it as AB or you can put it as BA. So you have to say 6 factorial multiplied by 2 factorial. This 6 factorial is just us realizing that the 2 books must always be close to each other. So we no longer have 7 factorial anymore, but 6 factorial. But still, if those 2 books are close to each other, we don't have to necessarily arrange them in one way. You can say AB or you can say BA. So that is why we are multiplying by 2 factorial. Right. Counting principle is very interesting. You have to think about all possible scenarios. You cannot leave anything out. 11.3.3. If all the economics books must be placed next to one another and all the life science books must be placed next to one another, in how many ways can you arrange the books on the shelf? So again, let's go ahead and have those slots. 1, 2, 3, 4, and then 1, 2, 3. So let's say we have A, B, C, D, E, F, G. So these are the 4 economic books. We're taking them as one slot because they must always be next to each other. And these are the 3 life science books. We're taking them as one slot also because they must always be next to each other. So it's either you're going to start with the economic slot and then the life science, or the life science first and then the economics. So there's 2 factorial ways we can arrange that. But I want you to realize something. Let's get inside the economics books. So if you get inside the economics books, you're going to realize that we have 1, 2, 3, 4 books, right? So there's 4 factorial ways of arranging the books inside the economics slot. So this is 4 factorial. Multiplied by the life science books, we have 1, 2, 3 books. So there's 3 factorial ways of arranging the life science books inside the life science slot. So this is 3 factorial, which is 288.